write the heading of today's class. It's application of a Laplace transform. Application of Laplace transform. Okay, application of a Laplace transform in transient. In transient. Okay. So, suppose I am giving you one circuit, that my circuit is like this, I of t, it having a resistance R, that is my R resistance, and positive to negative it's V of t, and that is I of t. So V of t is equals to R into I of t. If you want to convert this into the Laplace transform, it will become capital V of S into R into I of S. Okay, so the circuit will be look like this: positive, negative, V of S, this will R, this particular is your I of S. Just do it. Okay, so what I am telling, if you want to convert your circuit in a Laplace domain, so this is your V of t, this is your I of t, and this circuit is resistance is R, so V of t is equals to R into I of t. The Laplace conversion will be V of S is equals to R into I of S. So V of S means it's a conversion. Okay, so if you'll do it for inductor, so in inductor, so this was for resistor. Okay, just wait. So this was for inductor, and if you'll do this was for resistor, and if you want to do it for inductor, this inductor look like this. You have positive, negative, V of t, this is your I of t, and this is your L. Okay, and I told you in the first class itself, V of t is equals to L di by dt. So if you want to convert this in the Laplace domain, if you want to convert, so it will become V of S into L. And what is the differentiation of it? Means what Laplace transform of the differentiation? I told you yesterday itself, it will be Si of S. S will come and I of S function will come. But for differentiation, one initial function is also coming. Okay, one initial function is also coming. That is your I of 0 plus. It will be given. If it is not given, so it will be 0. Okay, so V of S will be Ls I of S minus L I of 0 plus. Okay, remember one thing, means if you are having a this term dx by dt, we will discuss these things in signal system and in control system again, but for now remember this thing: dx by dt, the Laplace transform of dx by dt is x of s minus x of 0. This is your initial condition. Okay, for if the function was d square x divided by dt square, then what will come? Okay, then
S square into.
Yeah, s I forget here. S will come. So here you will get what? You will get S square,
S square
yes, S square
x of s.
x of s. So, but here also the initial condition will come. Okay. So what will be the initial conditions? That's what I am asking. What will be the initial condition in this case? S square x of s minus s x of s minus x dash of 0 means there is a 2 3 initial conditions coming. That's what I am asking. So have you studied these things in your btech? Means what is the initial conditions of a d square x by dt square? Have you studied, Venka? Have you studied these things?
Yes, sir. Yes, yes. Yes.
So what initial conditions we are getting? S square x of s minus s x of 0 minus x dash of 0. This function will get. Okay, how so? I will tell you. See, uh, if you remember this formula now, this formula can be derived from this. So this is our dx by dt, and we are doing again differentiation d by dt. Okay, what is the Laplace transform of this? S x of s minus x of 0, right? Laplace transform of this. Okay, again one differentiation is coming, so that's why 1s will come, and the value, this is your x dash value, this meaning your differentiation value, so it will be subtracted by x dash of 0. So what we are getting, s square x of s minus s x of 0 minus x dash of 0. So this, what is this x dash? Dx by dt, t is equals to 0, whatever the function will be. Okay, so don't get means like a fear and all. What I'm telling now, this question is this question is not very difficult. Means this concept is not very difficult. So you having a v of t is equals to l di by dt. So if we'll convert it into a Laplace domain, so v of s is equals to l s I of s minus I of 0 plus or 0 minus, whatever you will say. So you are getting what function? Means see, di by dt, the Laplace transform of di by dt is what? S I of s minus I of 0, and this l is multiplied with this, so we are getting l s I of s minus l I of 0. Actually, the Laplace transform of dx by dt is s x of s minus x of 0. If you remember this thing, so you can find for uh, d cube x by dt cube also Laplace transform. So here we need to find d square x by dt square. So I write this particular term, this particular term means d by dt into dx by dt, and we know the Laplace transform of dx by dt is s x of s minus x of 0. Okay, and 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 this is my x dash, dx by dt is my x dash, so that's I am writing x dash of 0. I'm substituting in this form only. Okay, how to say, let's suppose dx by dt is your y function. Okay, and you are doing the Laplace transform of dy by dt. So what you will get? S y of s minus y of 0, right? Y of 0, and this y can be represented as x dash. X dash means it's a differentiation function. And what is the Laplace transform of this particular dx by dt? What is the Laplace transform of y of s? Y is dx by dt. So what is the Laplace transform of y of s? S x of s minus x of 0. So if you will substitute the value in this y of s, you will get s x of s minus x of 0 minus y of 0. So you are getting what? You are getting the same result, s square x of s minus s x of 0 minus, and you can write y of 0 as a x dash of 0. Priyanka, have you understood this thing, what I am doing? And dy by dt is nothing but d square x by dt square. You understood, or you want one more explanation? Priyanka?
This last one, sir. Can you explain?
Okay. See, the thing is that means I'm telling you from a basic means it's a very important. If you all understood these things, now it will be very easy for you. See, dx by dt can be represented as x dash. This thing is clear. Dx by dt can be represented,
Yes, sir. Yes, sir.
and we can represent. I am representing this with y. Okay. I am just assuming this is equals to y. Is this clear?
Yes, sir.
So if I will do again differentiation, so what you will get? D square x by dt square is equals to,
X double dash.
yeah, x double dash, and it will be y dash. Is this clear?
Yes, sir. Yeah.
So what I'm telling, is this clear? Right? Up to here it is clear?
Yes, sir. Yeah.
So what I am telling you, see, and we can write like this also. This d square x means d by dt I am taking as a common. I have dx by dt. So I can write dx by dt value is what? It is y. I can write like
Right?
this,
Yeah.
dy by dt. Right? Is this clear? I can write like this now.
Yeah. Yeah.
So
Yeah.
if I want to do the Laplace transform of dy by dt, what is the formula? Sy of s minus y of 0. Is this clear? This is your
Yeah.
initial. This y of 0 means what? Suppose your y function is t square plus 3t, something like this, plus 5. Okay. And what is your y of 0 means? Means the value of t is equals to 0, what the function is coming. So 5 is coming, you need to put the 5 value. That's it. It's very simple. If overall value will come 5, you will get these things very familiar, means you will be very familiar if you will practice these things in maths. We'll discuss it again in a maths. Okay. So for now you have to understand this y of 0 means what? It's t is equals to 0. Okay. The value at t is equals to 0, what we are getting. Okay. Now what I am asking you, y is dx by dt, right? Y is dx by dt.
Yes, sir.
So what will be the Laplace transform? Y of s is equals to sx of s
Yes,
minus
into
x
y. X of
minus
s.
minus x of 0.
X dash of.
X of 0, not x dash of 0. X of 0. Why will be x dash of 0? Because we are doing for dx by dt, na? So there will be no x dash. Means when we'll substitute this, then x dash will come.
Single term. Yeah.
Yeah. So sx of
Yes,
s
sir. Yeah.
minus x of 0, and this is y of 0. So what I am getting, s square x of s minus x of 0, and y of 0 means what? Y of 0 means what? I can represent in this term x dash of 0. Right? Now what is the meaning of this? Suppose you having a dx by dt term like this, t cube plus 4t square. Let me correct it. So suppose you have the value of x value is t cube plus 4t cube plus 5, like this. So what is the x of 0 value? X of 0 value is, substitute t is equals to 0, you will get 5. And what is x dash of 0? X dash of 0 means dx by dt. So differentiate it. 3t square plus 8t. Okay.
80 plus.
plus 0.
Yeah, that's it. That's it. Yeah.
And you have to put the value of a t is equals to, now you have to substitute the t is equals to 0. You will get 0 value. So your x dash value is coming here as a 0, and x of 0 value is coming as a 5. So you are getting s square x of s minus 5. Is this clear? This formula is clear.
Yes, sir. Yeah.
Now if you understood this concept, now you can find any Laplace transform like this: d cube x by dt square, d to the power 4 by dt to d to the power 4 x by dt to the power 4. So you can find like this. It's up to you. If you understood this concept, generally a lots of student struggle in this formula. How means they are getting confused, is this x dash square or x 0 square. So if you can do like this, if you will solve like this, there will be a no confusion. Am I right? Or still you are facing any confusion? So
Yes, sir. Yeah.
so now why I am teaching you these things, because uh, if you will see, I have a inductor, right? This I am giving a positive negative supply v of t, and I have a current I of t, and this is my L. Okay, so what is the formula of an inductor? Inductor is v of t is equals to L di by dt.
Demoted.
Now if you will do the Laplace transform, what you will get? V of s, take L common, because, and what is the Laplace transform of di by dt? S I of s
S
minus
into I of S minus I of 0.
minus I of 0. Great. So how can we represent this V of s? Ls I of s minus L I of 0. You understood? L is multiplied.
Yes, sir.
Now this is what? This is voltage, right? This is voltage. This will also represent voltage only. And this meanings of voltage cannot be subtracted by current. If you are getting a voltage here, so this will be a voltage and this also be a voltage. Okay, this is also a voltage. So how can you make the circuit? You are getting V of S, right? Right, you are getting V of S. And what current is supplying? I of S current is supplying. So I of S current is multiplying with what? Ls. So I am writing here Ls, and I am getting here a minus Li of 0. So I am writing like this: negative, positive. I am writing like this: Li of 0. Means this is your initial current. So now make the KVL and you will get the same equation, that V of S is equals to Ls I of S minus L into I of 0. You understood how we did it? Priyanka, understood? V of S is equals to Ls into
Yes, sir.
Ls
Yeah.
into I of S minus L I of 0. So V of S, this part is my positive part, and this part is my negative part. So if I am going from this way, I am getting V of S value is Ls into I of S, like this only. So from these particular equations I made this circuit. From this particular equation I made this circuit. Right? And I taught you one thing, a source transformation. Okay, source transformation. If assume this is your resistor, means things like this is your resistor, and here you are getting a voltage. So voltage and resistor can be converted into current. So how can you do it? This is your I of S current. A resistor will come in parallel, so this impedance is coming in parallel, Ls. And if you want to make your current source, so this arrow, this is showing your positive and it's negative. So what will be? Li of 0 divided by Li of 0 divided by Ls. Li of 0 divided, so Ll will get cancelled out. So this can be written as I of 0 by S. Source transformation. If you remember, means if you are having a positive negative this side and this is R, so you can convert this circuit like R, and because now here upside is positive, so I have to make the arrow like this, and if it is E, so the current will become E by R. So same thing I did. This is like a resistor only, Ls. It's a reactance basically. So and this is my voltage. So I divided this voltage by this reactance. So I am getting a current source I of 0 by S, and this will come in parallel. Is this clear? Is this clear? Priyanka, is this clear?
Yes, sir.
Okay. Now if you have no doubt in this, so we'll do the same thing for capacitor. Capacitor. So this particular is your capacitor, and this is I of t. Now you tell me the thing. So what is the equation of I of t is equals to? I of t is equals to C dV by dt. Am I right?
dV by dt.
Now if you will convert this particular thing in Laplace transform, what will be the result? I of S,
I of S equal to
C bracket
S into I of S.
S into V of S, dV by dt na? V is there na?
Numerator, yeah.
V of S minus V of 0.
V of 0.
Okay, this V of 0 is your initial condition, V of 0, small v of 0 only. Okay, so better to write like this, in a small way, this initial condition. Okay, 0. Now I of S will be CS V of S minus CV of 0. So this is your current source now. So this will be your current source, this will be your current source. So how can we represent? I am getting a current source of I of S, and one current is going, and one current is, I am taking one current is coming, so that the result will get the negative. Okay, I am making this as a current source, and the here voltage is positive negative V of S, so the voltage will be V of S only. So V of S is getting divided by okay, so V of S will be getting divided by 1 upon CS. So I have to write like this. In a capacitor, in terms of a reactance, we are writing 1 by C of S. So V, what is the current formula? V by R. So R is what? Means your reactance. I'm writing in terms of a X. So X is what? X is 1 by CS. So that's why I have written like this, 1 by CS. So V of S will be divided by 1 by CS. So you will get V of S into C into S. And what it will be? What will be the value of this? This is simply CV of 0. So what current you will get? See the equation and match. I of S, incoming current, outgoing current. This is your incoming current. This is your outgoing current. So outgoing current V of S into C of S, and what is the one current is incoming, so minus sign will come, CV of 0. Understood? Understood or not? Just tell me.
Yes, sir.
Now, if you understood, now you have you can convert this into the current this into the voltage transformation also, na? You have a resistance, you have a current. So if you want to represent this in terms of voltage, what will be the results? A capacitor will be remain like 1 by Cs, and what the voltage you will get? Positive, negative multiplications of this. Multiplication of this will come how much? Cv of 0 into 1 by Cs. So C will get cancelled out. So S will be there. S will be there. So you will get V of 0 by S. So this will be positive, negative V of S. Both are same only. We did the source transformation. Is this clear? Is this part is clear? And the current is flowing in this is I of S. Priyanka, is this clear?
Yes, sir.
Okay. So yeah. Now do some questions. Do 2-3 questions is there, and by questions you will understood more clearly. After that we'll start the resonance. See. Okay. Now the transient can be solved by Laplace transform. How so? I will tell you. You have a question. Find I of t for t greater than 0. And when you will apply the Laplace transform? When you will get you are getting your L and C both are connected in series, like that conditions only you should use Laplace transform. Laplace transform is like a Brahmastra. Means if you are not able to solve from switching, closing and opening, you can use directly Laplace transform. Okay, 50 volt is there, and this is 2 ohm, and this particular is your 1 Henry, and this is your positive, negative 1 by 2 amp. So no initial condition is given basically in this question. So your I of 0 minus is equals to 0, your V of 0 is equals to 0. So there is a no initial conditions. Okay. Now, and yeah, I just want to tell you one thing. What is the Laplace transform of a constant term? The Laplace transform of a constant terms, like a voltage source is there. So you will get the Laplace transform is K upon S. Okay. If some signal is like this 50 volt means what? It's coming from minus infinite and going up to infinite. So what will be the Laplace transform of this 50 volt? It will be 50 by S. Okay. Actually, I just want to tell you, it's not like that. It's 50 volt is actually your unit impulse. Okay, because this circuit is starting from 0. From 0 it's getting 50. From 0 to infinite it's getting 50. So this function can be written like this, u of t. Okay, we'll discuss these things in a signal system very clearly. So x of t is here, this t is here. So it's starting from 0 and it's going up to infinite. So this is your unit step function, and the Laplace transform of unit step function is 1 by s. Okay, for now just remember this one. This is the unit step function. So step function means it will start from 0 and it will go up to infinite, u of t. So I can write this circuit instead of this, because 50 volt, this 50 volt is getting on at what time? 0 time. Before that this circuit is not getting any 50 volt, right? And the signal, this signal u of t means what? It's starting from 0 and it's getting up to infinite. If we'll write 50 u of t, so that means the value is 50. So we can represent this circuit like this also, like this also, 50 u of t. Okay, because u of t means from minus infinite to 0 the circuit is closed, nothing was there. So basically instead of this switch we can write like this also, u of t. Okay, and what is the Laplace transform of a step function? Always remember 1 by s. So if we convert this particular Laplace transform, and this is your 2 ohm and this is 1 Henry and this is 1 by 2 farad. So if we convert this particular circuit in a Laplace transform, you will get positive negative 50 by s. This will be 2. This is 1 Henry. Okay. Now I will tell you what is the Laplace transform of this. We had already seen the Laplace transform of inductor is Ls minus L of I of 0. Ls minus is this Ls and some potential is coming. Some potential is coming. So let me write like this. Okay, Ls minus plus L of I of 0. And what is the Laplace transform of a capacitor? Capacitor in terms of voltage, 1 by Cs. Okay, 1 by Cs, positive negative V of 0 by S. 1 by Cs, positive negative V of 0 by S. But this value is 0. Okay, this V of 0 value is 0. This Li of 0 value is 0. So your circuit will be simple like this, Ls, R and 1 by Cs. 1 by Cs, and this will be positive negative 50 by S. So now apply the you need to find the I of S. So this is, so what will be the I of S? This is your V of S. So V of S divided by R plus Ls plus 1 by Cs. Substitute the value. V of S value is 50 upon S, and R is your 2 plus L was 1, so S plus capacitor was 1 means 2 value, capacitor value was 1 by 2, so C value is 1 by 2, so 1 by 2 into S. Okay, if you solve this, what you will get? 50 divided by S, 2 plus S plus 2 by S. Okay, if you will solve this, so 50 into S divided by S square plus 2S plus 2. So this will get cancelled out. So I of S you are getting 50 divided by S square plus 2S plus 2. Right? You are getting S square plus 2S plus 2. Now you need to convert this into I of t. So you should know the Laplace transform. Means okay. So this can be written like this. We can write S square plus 2S. So we can write S square plus 2S plus 1 plus 1. Right? This is your A plus B the whole square formula. So 50 divided by s plus 1 the whole square plus 1 I of s. Okay. uh, so don't get nervous by seeing this. Okay, we have to discuss these things very separately. I'm just telling you, don't get nervous by seeing this kind of a complex equations. You will be a very comfortable when you will study the signal and system. So please don't get nervous. If you are getting a nervous in by seeing this kind of a uh, uh, this kind of a yeah, this kind of a sum. Okay, so what is actually, just what I want to tell you, uh, just write it here. Sine t, Laplace transform of sine t will be, transform of the sine t will be sine t. If you want to convert the Laplace transform of sine t, so or write like this: sine at, Laplace transform of sine at is a divided by s square plus a square. Okay, a divided by s square plus a square. And if you are getting some function in this, like what is the Laplace transform of e power minus at? E power minus at Laplace transform is 1 divided by s plus a. Okay, now you see, you are getting one delay. So here a is 1, a is 1. 50 I am taking as a common. 50 I am taking as a common. You are getting 1 divided by s plus a the whole square plus 1. Okay, so this s plus a means you are getting e power minus at, and this a divided by s